right? We have, for the inverse, we're going to have 4 going to 2 places. So that's not a function. So in that case, we say that this original function, does not have an inverse. Does not have an inverse. Okay? So if you end up with, when you consider the inverse, if you end up one thing going to 2 places, that's a problem. And so we say it doesn't have an inverse. So when does that happen? When you look at the inverse, you have one thing going to 2. When does that happen? That happens here when 2 things go to 1. Now 2 things are allowed to go to 1. This is a function. G is a function. 2 things are allowed to go to 1. Remember, the problem for functions is not that 2 things go to 1, but that 1 thing goes to 2. Right? 2 things are allowed to go to 1, but 1 thing is not allowed to go to 2. So this is not allowed, but this is okay for a function. But when we have this, when we have 2 things going to 1, then we don't get an inverse. So when we have 2 things going to 1, we're going to give that a special name, and then say when that happens, we don't have inverses. So that name is called a function. Well, actually, sorry. As long as 2 things don't go to 1, we're going to give that a name. A function is called 1 to 1 if, when f of a equals f of b, that means that a must be equal to b. In other words, the only time f of one thing can be equal to f of something else in the domain, a and b are in the domain, is if those 2 things are actually the same point. You can't have, in other words, you can't have 2 separate things, a and b, going to the same place. So this is called 1 to 1. Basically, it just means that you don't have this. You don't have this. If it's 1 to 1, you don't have that. Okay, you don't have a and b both going to the same place. The only way that a and b can both go to the same place is if a is actually equal to b. That's what this says. If f of a equals f of b, then a actually has to equal b. So that's called 1 to 1. So now we can say a function which is 1 to 1 has an inverse. And a function that is not 1 to 1 does not have an inverse. If you want to think about this visually, when you have 2 things going to 1, what does that mean in terms of the graph? It means you have 2 things, A and B, for example, going to the same height. So in other words, if you had a picture like this, so is that 1 to 1? No, it's not, because, for example, A, let's say A, this A here, and this value here, well, if I drew it right, both go to the same height. So you have 2 things going to the same height. So just like before, when we wanted to see whether whether something was a function or not, we had a visual test. Remember, we said this is not a function. The visual test was check a vertical line. If you can cut it in 2 places, then it's not a function. Now we can have a visual test for whether something is 1 to 1, and that is if you can draw a horizontal line and cut it in 2 places, then it's not 1 to 1. So that's a test for 1 to 1. We could call it the horizontal line test. So let's just do an example to check to see if a function is 1 to 1. So we could do the horizontal line test, but let's just do it with the original definition. So let's suppose we take the function f of x equals x squared, and the question is it 1 to 1? And of course we know it's not, because it looks like this, or it could look like this, and that's not 1 to 1, but let's do it with the definition up here. So what do we have to test? For example, is f of 1 equal to f of negative 1? So is that true? Because, of course, 1 is not equal to negative 1. So if f of 1 is equal to f of negative 1, that violates this, because if this is equal to this, then we said they have to be the same. But here, 1 and -1 are not the same, but what about f of 1? Is that equal to f of -1? Yes, of course it is, right? They're both equal to, this is equal to 1 squared, this is equal to -1 squared, and they're both equal to 1. So in other words, what we're saying is that -1 and 1 both go to the same height, and so that's not allowed. So this function, x squared, y, say y equals x squared, is not, this is another way to write it, 1 to 1. Okay, so let's write down what we've said. If f is 1 to 1, then f inverse exists, and if y equals f of x, where f goes from a to b, so a is the domain, and b is the range for f, then f inverse of y equals x, where f inverse goes from b to a. So this is what we mean by the inverse of this function. So if y equals f of x, then f inverse of y equals x.